In the last lesson, we mentioned position time graphs and how they work and how they reference motion and how they can represent motion of any given object at a certain time. Now, in this lesson, we're going to focus on the velocity aspect of position time graphs. So the velocity aspect of position time graphs. Now, if we look at the first example here of this graph, we can see that the object is in a straight line. And as we mentioned before, the more horizontal the line is, the slower the object is moving. And the more vertical it is, the faster the object is moving in a position time graph. So if we look at over here, it's a horizontal line, and if we calculate the slope, it'll be equal to 0. So the velocity in the first graph is equal to 0 meters per second, meaning that there's no motion. The object is not moving. Now in the second graph here, we have a linear function graph. And in a position time graph, when there's a linear function, it means that the object is moving. And we can see here that at every certain period of time, it moves a certain amount of time. It moves a certain amount of distance. See here that it's actually even. If we were to calculate the slope, we would get the velocity. So calculating the slope gives us the velocity. Now this graph here represents constant motion. And where is the motion moving? Since we're mentioning velocity, we need to mention the direction. And since it's moving upwards, uh, it's moving in the positive direction. So here it's constant motion in the positive direction. So positive direction. So constant in positive direction. Now, in the second graph here, it's the same, similar to the first one, except it's moving downwards, meaning that as time goes by, the object is moving a negative distance or a negative displacement. So we can see here if we calculate the slope. So by calculating the slope, we get the velocity again. And in this case, it's going to be a constant velocity, so at a constant speed, but negative because it's moving in the negative direction, just downwards. So we can see here it's moving down, so it's negative. Here it's moving up. Here it's moving up, so it's positive. Now, moving on to the next example here, we have a velocity time graph, but it's curved. So when there's a curved time graph or a function, we know that it's to the second degree. So it'll be to the power of x squared, so it'll be 2 power. Now, in a first degree, we have whenever it's a linear line, then the degree will be 0. So, I mean, when it's a linear line, the degree will be 1. So x power of 1, or similar to the y equals to mx plus b. So the degree of x here is 1. And then here in the horizontal line, the degree is going to be 0. So degree of x is 0. So no slope, or the slope is 0. Now, for this graph, as time goes by, the object gains distance. Now, the amount of distance over time increases, meaning that the object is speeding up. So we can see here that over time, I mean, in this graph, as time goes by, the object is slowing down. You can notice this by as time goes by, the object loses speed. So the object it goes as time goes by, the distance between every point decreases, and at some point it'll reach a 0 degree horizontal line. So as we mentioned before, the closer it is to a vertical line, so if we look here at the beginning here, it's it's a pretty vertical line, then it gets smaller, more horizontal, becomes more horizontal, and you can tell here that it's slowing down. So slowing down, coming down. Now, in which direction is it slowing down? So, because it's still in the positive area, so this entire graph is still in the positive area, so it's slowing down in the positive v direction. So in the positive v direction. V stands for velocity, so it has to be direction. Now in the next graph here, as time goes by, the object is traveling a further distance, so travels a further distance every time. So by looking and just analyzing this graph, we can see that it's speeding up, and we can also prove it by just drawing the tangent line again. As you can see at the beginning, it gets horizontal, and then it gets less vertical, and less vertical over time. So again, it's a parabola, so the degree here is 2, degree here is 2, and it is speeding up. Now in which direction? We need to mention direction because it's velocity, so it's speeding up positive, in the positive v direction. Why is it positive? Because it is in the positive quadrant. So if we were to draw a negative here, it's in the positive. So here's negative here, here's positive. So it's speeding up in the positive v direction. The more time passes, the more speed it gains, and the more distance it travels. So we mentioned before that we want to focus on the velocity aspect of these position time graphs. So let's cover instantaneous velocity. Now, when we're talking about velocity, we mentioned that velocity refers to speed, so the magnitude, magnitude plus the direction. So to find the instantaneous velocity, we need to find the speed and we need to find the direction. So if I told you that object A is moving at a constant rate north, so object A is moving at a constant rate north, and I want to find, so what is the instantaneous, instantaneous velocity at point A? Well, we look at point A here, and we see that in 4 seconds, it traveled 20 meters. And we know that velocity equal to, we know that speed is equal to distance, so distance over time. So let's calculate the speed, which is equal to 20 over 4, which is equal to 5 meters per second. Now we calculated the speed, but we asked for the velocity, so the instantaneous velocity. So we need to add direction. Now we specified at the beginning that the object is moving north. So we simply mention here 5 meters per second north. So n. And that is the instantaneous velocity. So next up, we need to understand the average velocity. Now, when we want to talk about average velocity, we're talking about the change between, so the average velocity between two different points, and we want to find how fast it's going between these 2 points. Now, if I were to ask you, what is the average velocity from point A to point B, if the object is moving north, then what would I do? Well, first off, since it's velocity, we should mention both the magnitude plus the direction. Now, the direction here, since it's specified north, and over here it says north is positive, south is negative, so we can immediately dismiss uh, any negative values. Now, what is the average velocity anyway? Now, the average velocity is the average speed, so the average. So what is the formula for the average speed? It's equal to the distance over the difference in time. So we should also mention that it's an absolute value because we can't take any negative values. So that is the average speed. Now, combined with this, we can formulate another formula to give us the average velocity since we need to mention the direction. Now, the average velocity, so we could say so this is speed actually. Let me erase this. We'll mention it as the average speed or the speed average is equal to distance over time without direction. So no direction. Now, if we wanted to calculate the average velocity, so v average, we can specify velocity with an arrow. We could also have v but without the arrow, but it doesn't really matter. Now, v without the arrow, sometimes people like to refer to it as speed, so I'll just continue to put an arrow on top of the velocity whenever I mention the vector. So v average is equal to the difference, so delta x, so this is just x over the change in time, but this is delta x. So when we mention delta x, that means we need the difference. So we care about the change. We care about if the object is moving in the negative direction or not, and over delta t. So delta x over delta t will give us the average velocity. Now we can further break this down into delta x equaling to x final minus x initial, t final minus t initial. Now with all this said, let's calculate the average velocity from point A to B. Now we can simply list all the points out, so let's do that. X final is equal to 15 meters. X initial is equal to 10 meters. T final is equal to 10 seconds, and T initial is equal to 2 seconds. So with these values, let's input them into the formula, which is equal to, let's put this over here. So we have 50, so x final, so 50, we're simply substituting, minus 10, so 50 minus 10, with 10, so t final, minus t initial, so 2. Now if we calculate this, it's going to be 40 over 8, which is equal to 5 meters per second. Now, are we done here? No, because the question asked for the average velocity, meaning that we need to calculate the direction as well. So the average velocity requires direction, so we can specify north. So 5 meters north. We need to specify the direction, or else the answer is incorrect. Now, that is the average velocity. So just for a quick recap, the average speed, so speed is equal to magnitude plus nothing, only the magnitude, and velocity is equal to magnitude plus the direction. So we need to mention direction. Now, if we were to put the average of it, but then the average of velocity is the same, average of the speed is the same, and we get the formulas, and we can solve it and calculate the average velocity. Now let's solve this quick example on average speed and average velocity. So it says it wants us to calculate the average speed and average velocity from t equals 0 to t equal to 5 seconds. And it's mentioned that the motion is in only one direction, so it's either moving like this or it's moving like this. So we'll take the right side to be the positive direction and the left side to be the negative direction. Or it's already given to us. It says plus 50 here. So let's solve this question. We'll do the right side. We'll start with the average speed. So the average speed. So calculate the average speed. The formula we have is so v, so no vector, so just v. Average is equal to distance over delta t. So let's list what we have. So we have distance, which was we start from t0, so we start counting from here. 1, 2, 3, 4, 5, 6, 7, 8. So seeing as one unit is 10 meters, so that's 8 times 10. So the distance is equal to 80 meters. Now the delta t is equal to the change in time. So t final minus t initial. So let's just list out t init final, which is equal to 5 seconds, and t initial, which is equal to 0 seconds. Now, of course, it's 80 meters. We don't care about the direction at all. So we just add the total distance without caring for any direction. So we just substitute the form in the formula now. So we have 80 over, so t final minus t initial. So that's 5 minus 0. So it's 5. Then 80 minus 5 uh, is a calculator. 80 divided by 5. So 16 meters per second. Now, do we mention the direction? No, because it asks for the average speed. So now we do the next question. So the next question asks us for the average velocity. So average velocity. Now let's write the formula. So V average is equal to delta x. So the change in x, delta x over delta t. Now let's mention what we have. So delta x is x final, x initial. So what's x final? So we see here at t equal 5 seconds, it's 50 meters. So plus 50. X initial, it's negative 30. So we take the negative sign. If we don't take the negative sign, then it's incorrect. We need to mention the direction. Now, t final minus t initial, we already know, we calculated before, it's 5. So we can just say delta t is equal to 5 seconds. So now we just substitute. So V average is equal to 50. So final minus initial. So 50 plus negative minus negative 30. So minus times minus is plus. Remember the formula for delta x. Let me write it down here. Delta x is equal to the change, so x final minus x initial. We can't forget this. So 50 minus 30 over 5, which is equal to 50 plus 35, which is equal to 16 meters per second. And the direction we mentioned before, so if this is west and this is east, then it moved 16 meters per second east. And this is our answer. So in this next question, it's asking us for the average speed in the whole journey. So a car had moved for 30 minutes at an average speed of 30 kilometers per hour. Then it stopped for 15 minutes and then continued. So it stopped for 15 minutes. So it did not travel for 50 minutes. And then it continued traveling for another 10 kilometers at an average speed of 40 kilometers per hour. Now, uh, we can see here that there's like kilometers per hour, kilometers per hour, kilometers per hour. So let's just convert these two values into hours as well. So we have, let's just draw this first. Let's draw this journey. So a car, so this car had moved for 30 minutes, or let's just convert it into hours. So it's 0.5 hours divided by 60. A car had moved for 0.5 hours, an average speed of 30 kilometers per hour. So this is the first part, I guess you could say. Then it stopped for 50 minutes, which is 0.25 hours. So divided by 60 again, 0.25 hours. and then it stopped. So no, it did not travel anywhere. Then it continued traveling again, and then it continued to travel for another 10 kilometers. So it continued traveling again for 10 kilometers at an average speed of 40 kilometers per hour. Now we're missing two values here. So here we're missing this distance, and here we're missing the time. So let's split this into two questions. One, we calculate the distance, and here we calculate the time, and then we'll combine it all to calculate the average speed. So let's do the first step and let's calculate the distance. So in this segment over here, we have the formula for average speed is equal to V average is equal to distance over time. So we can just substitute it into uh, 30 kilometers, which is the average speed. Told us is the average speed is equal to distance. So we want to find the distance over time, which is 0.5 hours. And we can just shift solve here, and we'll get 15 meters. So in this segment, it traveled 15 meters. Now for the next one, it asked for the time here. We're looking for the time now. And we can do the same exact thing. We have the average speed, so V average is equal to distance over time. So 40 is equal to, we have the distance, so 10 over delta t. We're looking for time now. We can just shift solve here again, and we get 0.25 hours. So delta t here is equal to 0.25 hours. So now we have all the values, 0.25 hours. We can find the average speed. So the average speed of the whole thing, the average equal to uh, distance, so all the distances, plus uh, all the time. So time 1 plus time 2 plus time 3, or delta t. Now, now we just use the formula. So let's substitute the distance. So 30 kilometers plus 0 plus 40 kilometers. It's going to be 30 plus 40. And then time, we have it all in hours already. So we just add it. So 0.5 hours, 5 plus 0.25 plus 0.25. So give us 70. Uh, wait, this is the speed, not the distance. I made an error. So we're looking for the distance. This is distance. So 10 plus 15 meters, not kilometers. Km, kilometers. And then we get 25 over 1. So the average velocity is equal to 25 meters per second. And we don't mention the direction, of course, because it's asking for the average speed, not the average velocity. Now, for this question, it's asking us to find the average, so average speed, and we want to find the average velocity. So how do we find the average speed? So to find it, we simply add the formula. So B's average is equal to distance over time. So what do we have here? We have 400 plus 700, and we have our time. So we have all the variables we need. So 400 plus 700 over time, which is 4 minutes. We'll convert it into seconds, so times 60 for seconds, so 4 times 60. And then we put this in the calculator, and we get 4.58 meters per second. 4.58 per second. We don't need to mention distance here. It's just speed. Now, for the uh, next question is asks us to find the average velocity. So velocity, we need to specify direction. Now, if we want to find the average velocity, we need to find the distance of this line. So we need to find the displacement. So what's the formula of average velocity? It is the average velocity average equal to delta x over delta t. We can't just add these two, like in distance. We need to find the displacement, which is why we get this line. Now, how do we find a line of this triangle? So it's a triangle. We use the Pythagorean theorem. So c squared is equal to a squared plus b squared. So c squared is equal to 400 plus 700 squared. And then we calculate c squared. So 2 and we get 806. So c equal to 806 uh 806 meters. So now that we have this line over here, 806 meters, we can find the average velocity. But we need to calculate the angle as well. So instead of just saying south or whatever you want to do it, let's calculate the angle theta. So angle theta. Now, why don't we take this angle? Because again, it's easier to calculate it along the x-axis. So x-axis so here's the x-axis and here's the y-axis. It's easier to calculate theta when it's on the x-axis than when it's on the y-axis. It's less confusing. So let's take this angle over here, theta, uh, angle theta. Now, to find this, we can simply use tangent or we can use sine or cosine. Again, better to use tangent because the values are given, so we don't make any mistake. We do tangent theta is equal to 700 over 400. We're going to get around 60 degrees. So theta is equal to 60 degrees. So now we can calculate the average velocity. We already have all the givens. So delta x we have here is 806 meters. Just substitute displacement. And then the time is 4 times 60. So we get 806 meters over 4 times 60. So that's 3.58 meters per second. And then we need to mention the direction. We calculate theta here, so just 60 degrees. Now for this kind of question, we need to understand the difference between a secant line and a tangent line. Now a secant line is a line that connects two points. Like if we look in this graph over here, we have a line and it's connecting point A and point D. So this line is a secant line. Now calculating the slope, so calculating the slope of a secant line will give you one piece of information that's very important, which is calculating and finding the velocity. So as we said before, the slope of any line on a position time graph represents the velocity. So slope is equal to velocity. So why draw a secant line? Well, if there's a curve over here and we want to find the average velocity, or we want to find the velocity, we need to find the slope of a secant line. So we draw a line between 2 points, and in the test, if they do tell you to find the slope of the graph from A to D, or the velocity from A to D, they don't have to draw the secant line over here. You have to draw it on your own. So you should know how to draw a secant line. So for example, if I ask you to find B to C, then you will draw a line like this and you will find the velocity, or you will find the slope. So it's not always given. Now to find the values here, we simply find the rise over run. So we will do y1 minus y2, so 75 minus 50, and then 30 minus 20, so 30 minus 20. This will give us 25 over 10, which is around uh, 5 over 2. So this is the slope. Next up, we want to find the slope of the graph at point B. Now, in this question, it's asking for the slope at a specific point, which is point B. Now, when we find the slope of a specific point, and only one point, then it's called a tangent line. So we said the secant line connects 2 points, but a tangent line is only 1 point. So it would only intersect at 1 point. So we can just take any 2 points here to find the slope. So if we wanted to like extend the line a bit, we would take this point over here and this point over here, and uh, we would kind of estimate the value. So this is around 25 almost, and this is 50. So we would do it again. So we would rise over run, rise over run, and it's equal to 50 minus 25 over 28, or 20 minus 10, or 30 minus 10, 30 minus 10, which is equal to 25 over 20, which is around 5 over 4. That's our answer. So what we learned is the difference between a tangent line, which connects only 1 point. So tangent connects 1 point only, and secant 2 points. So we need to know the difference between them. So earlier we mentioned when in a position time graph, when two lines are intersecting, uh, either they will be meeting with each other, so they will meet and then they will cross paths, or or one line is going to beat another line or surpass one. So when it's intersecting, it means that one line is going from one direction and the other line is going to the other direction. Surpassing would be one line with a greater slope than another line, but they're both going in the same direction. So, knowing this, let's solve the first question. We want to find A to D. What is it doing? Is it meeting at face to face, or is it side to side? So, side to side in the same direction. So, let's look at A to D. So, A and D, line A. So, this is line A, and this is line D right here. So we can see here that line A is going that way and line D is going this way. So you can clearly tell that it's crossing each other, meaning that they're going to go in opposite directions. So A to D would be face to face. A and D would be face to face. Now D and B, let's look at line D. So this is line D, and this is point B. So it's asking us what is it doing at point B? Now, they're both going in the same direction here, so they're both going to be, uh, they're not going to be crossing each other. But in this case, one line has a greater slope than the other line, meaning that their slopes, they're not going to be a parallel line. So that means they're going side to side, but in the same direction, which is why it's not face to face. Now in the final one, C and D, so this is C over here, which is this line, and D is this line. So basically the same thing, except here it started a little faster. So it would still be face to face since they will meet at a specific point, which is here. Same with A and D, they will meet here. C and D will meet here, and then they will go their separate ways. Oftentimes, when you receive or have a graph, it's better to use an equation instead of always using a graph to describe it. Like there's a straight line, an xt graph. Instead of using an equation, instead of using this graph to calculate the slope and all that, we can use an equation, which is a lot more simpler and is a lot more efficient at times. So whenever there's a straight line, we will always use the form of y is equal to mx plus b, where m is the slope and y is the values. So when we want to find the first equation of motion, we need to use a straight line, and that is what exactly it is. It is a form of y equal mx plus b, except substituting some of the variables. So in the first equation of motion, instead of having y, we have x, which is equal to the velocity, so the average velocity, so v instead of m. So we swapped out m for v, and then instead of x, we have time. So vt. So if you already noticed, this is already a formula that we know of, which is x is equal to velocity times time. And then we need to also add the initial velocity, or the initial position, which is x initial. So this is our first equation of motion. It gives us equation and a way to represent a position time graph without having to use the graph. It's an equation for this entire graph. Let's solve this question on the first equation of motion. So here we have a cyclist traveling along a straight path. So a straight path, obviously, because it's a linear graph, and it maintains a constant velocity. So, of course, a linear line. And the constant velocity is 5 meters per second west. So once you see west, you should immediately note that the velocity is negative. So negative 5 meters per second west. And at a time interval of 0.0 seconds. So this is 0 point, this is seconds, not 0.05. Make it more clear. So seconds. At 0.0 seconds, the cyclist is, so at t is equal to 0, the cyclist is at 250 meters west, so negative again, so negative 250 meters of point A. So if we actually wanted to draw this, then the graph would look somewhat like this. So you have the negative values, so it would be around 250 meters to the negative side, while also going with a negative slope. So it would be like negative. So like that kind of. So a negative slope. So this slope is negative 5 meters per second. This is negative 250 meters at time, or point A here it says. Now, what is a cyclist's position from point A to 60 seconds? So it's asking us, after 60 seconds, what is its position from point A, which is the origin. So if we wanted to do this, we can use the formula. So x final, which is the final position, is equal to v average. So we need to get the average speed or average velocity multiplied by the time plus the initial position, so x initial. The initial position here is, of course, negative 250 meters, and the velocity, the average velocity, since it said constant velocity, so immediately know that it's the average, which is negative 5 meters per second. It's a straight line, so yeah, it won't change. So velocity is constant. So we can simply substitute here. We don't really need to do anything. We have the time. We have the uh, values, so we just substitute. So x final, so this is what we want to find, is equal to average velocity, so negative 5 meters multiplied by the time, which is 60, and then we add the initial position, which is negative 250 meters. And if we just do the math with a calculator, we get negative 550 meters. So this will be its position at t equals 60. So at t equals 60, this is the final position. Now, the second question, question B asks us to calculate the displacement. So delta x from A to 60 seconds. So at 60 seconds, it was negative 550 meters. So this is our final position, and this is our initial position. So x initial and x final. So we already know the formula for this. It's delta x is equal to x final minus x initial. So we simply substitute. So x final is negative 550 meters minus negative 250 meters. And if we do the math, this will convert to plus, and it's plus 250 minus 550, which is equal to 300, negative 300 meters, and that is a displacement. Now, the final question we're going to solve is going to be this one, where it says two cars travel along a straight road. So again, a linear line. However, this time we have multiple objects in the same position time graph. So we have xt here. When a stopwatch reads t is equal to 00 hours, car A is at xa 48 kilometers. So we know here that when it's at 0, t is equal to 0, and there is a position, then this is the initial position. So we have car A. Let me change the color. We have car A at 48 kilometers and is moving at a constant speed. So it's moving up at a constant speed of 36. This is 36 miles per hour. Now, later, so for the second car, when the watch reads t is equal to 0.05 hours, car B is at x b equal to 0.00 kilometers. So here it says that at t is equal to 0.5, so 0.5, car B is at x b 0.0 kilometers. So it's at here, and it's moving up with a greater slope. And eventually, they're going to intersect, since they're both linear lines, and one has a greater slope, so the slope is 48 kilometers per hour. Now, this may not be the most accurate graph, but it's just for the sake of the concept. So, knowing this, the question asks us, what will the watch read? So, we're asking for time here. So, delta t, we don't know. What will it read when car B passes car A? So the best thing we can do in this question is just list out all our variables. So let's start with car B. So car B, we have t equal to 0.05 hours, or 0.5 hours, sorry. And we have x initial equal to 0 kilometers. Now for A, we have, and we want to, and we don't know, when we know the acceleration, or not the acceleration, the velocity, which is, so v average, which is 48 kilometers per hour. Now for car A, we can list them out. So t is equal to 0.0 hours, then x initial is equal to 48 kilometers. And their speed is at 36 kilometers per hour, so average velocity is 36 kilometers per hour. So what do we know about the point where they intersect? Well, we'll know that the final position, so x final, will be equal. So x final of A would be equal to x final of B, right? Because they're at the same position in this position time graph. So we can use the equations of motion that we learned. So if we just write it out, x final is equal to uh, v average times delta t plus x initial. So this is the formula. We can say that they're equal to each other. So x final of A is equal to x because that's what it is. That at this point, their final velocities are equal to each other because they intersect. So if we just substitute it, so v average times time plus x initial is equal to the average of the other car, we can calculate the time. So we can just start with B here. We substitute, so the average, so 48. We want to find the time, so we don't use the time. Then plus x initial, which is 0. The v average is 36 for A. Delta t, we were looking for the time at which what the watch reads. So we want to find the time at which the watch reads. So 48. And if we just use a calculator and shift solve, we get delta t is equal to 4 hours. So this is the time at which uh, the watch is reading. So the watch would like here it says 4 hours or whatever. And this is the time at which car A passes car B. So at this point right here, 4 hours. That'll be it for lesson 2.4, how fast. If you have any questions or want to ask anything at all, you can ask it down below in the comment section or in the server. If you want more videos like these, you can find them on the channel. And yeah, enjoy them.